Audio Jungle. Audio Jungle.
Isomerism definition, types, structure, examples, and FAQs. In the year 1827, chemistry scholar Frederick Wohler prepared cyanic acid and got surprised that the chemical composition of the formed substance was identical to the fulminic acid, but the properties of this acid are very much different. This finding created shockwaves in the science scholar community, as at that time it was considered that chemical compounds can only have different properties if they have different elemental compositions. After some discoveries of some sort, this was considered a scientific phenomenon, and Jacob Berzelius named this phenomenon isomerism. What is isomerism? One of the most essential features of organic molecules is their propensity to show isomerism. Two or more compounds with the same molecular formula but different physical and chemical properties are known as isomers, and this property of a compound is known as isomerism. Types of isomerism. Isomerism can be classified into two categories as follows. Structural or constitutional isomerism. Stereoisomerism. Structural isomerism. The constitution of a molecule refers to the quantity, kind, and connection of its atoms. The structural isomers or constitutional isomers differ in the connection of their atoms, and this phenomenon is known as structural isomerism. It is also known as constitutional isomerism. Because they have the same molecular formula, ethanol and dimethyl ether are isomers. C2H6O. Because the atoms in each chemical are bonded differently, they are structural isomers. The following are some examples of structural isomerism in various forms. Chain isomerism. Position isomerism. Functional isomerism. Metamerism. Tautomerism. Ring chain isomerism. Chain isomerism. Chain isomers are isomeric substances that differ solely in the arrangement of carbon atoms in the base chain, and chain isomerism is isomerism between them. The carbon atom chain or skeleton differs amongst isomers of this type. Carbon atoms can be arranged in a straight or branched chain. Chain isomerism does not exist in molecules comprising up to 3 carbon atoms, since they are a continuous chain with no chance of branching. It is demonstrated for compounds with 4 or more carbon atoms. Chain isomerism in alkanes, alkanes containing 4 or more carbon atoms. For example, two chain isomers are represented by the chemical formula C4H10. Chain isomerism in alkenes. When writing chain isomers for alkenes, the position of the double bond should not be modified. For example, two chain isomers are represented by the chemical formula C4H8. Chain isomerism in alkynes. Chain isomerism occurs in alkynes, which are compounds having 5 or more carbon atoms. The two chain isomers are represented by the chemical formula C5H8. Position isomerism. Position isomerization is a phenomenon that occurs when two or more compounds differ in the position of a component atom or functional group on the carbon skeleton. C3H8O, for example, is made up of two alcohols. Functional isomerism. Two or more molecules with the same chemical formula but distinct functional groups are called functional isomers. Functional isomerism is the term for this occurrence. For example, the chemical formula C3H6O denotes both an aldehyde and a ketone. Metamerism. Metamers are molecules that have the same chemical formula but differ in atomic or group locations on both sides of bridge functional groups. Metamers are distinguished by the nature of the alkyl groups surrounding a certain functional group. As a result, they have a connection. For example, the chemical formula C4H10O accommodates 3 metameric isomeric ethers. Tautomerism. Tautomers are functional isomers that exist in dynamic equilibrium at the same time. The most prevalent kind is ketoenol tautomerism, which is caused by the 1,3 movement of the hydrogen atom from carbon to oxygen and vice versa. For example, tautomerism in an aldehyde or ketone requires the existence of a hydrogen, which is involved in 1,3 migration. In the lack of a hydrogen, tautomerism is absent. Acetone, acetaldehyde, and acetophenone, for example, might display tautomerism due to the existence of a hydrogen, whereas benzaldehyde and benzophenone do not due to the absence of a hydrogen. Ring chain isomerism. Ring chain isomerism is structural isomerism that differs from the other structural isomers discussed previously. It is present in isomeric open chain and cyclic molecules. Compounds with the same chemical formula but open chain or cyclic structures are known as ring chain isomers. And this phenomenon is known as ring chain isomerism. The ring chain isomers are represented by the chemical formula C3H6. Stereoisomerism. Stereoisomers are compounds that have the same chemical and structural formulae but differ in the relative arrangement of the atoms or groups in space, a phenomenon known as stereoisomerism. Stereoisomerism can be divided into two categories. Conformational isomers. Conformational isomers are stereoisomers having different relative positions of atoms inside the molecule that can be interconverted by rotating around sigma links. In other words, there is no need to break and remake covalent bonds in order to interconvert these isomers. Configurational isomers. Stereoisomers that can only be interconverted by breaking and reconstructing covalent bonds rather than rotating around sigma bonds are known as configurational isomers. Geometrical isomerism and optical isomerism are the two types of configurational isomerism. Geometrical isomerism. Isomerism generated by constrained rotation around a link in a molecule is known as geometrical and also called cis-trans isomerism. A wide range of substances exhibits geometrical isomerism, which can be characterized as follows. C is equal to C, C is equal to N, and N is equal to N are examples of compounds with double bonds. A cyclic molecule, including homocyclic, heterocyclic, and fused ring systems. Steric hindrance compounds prevent rotation around a single bond. Biphenyls, for example. Optical isomerism. Certain chemicals can exist into stereoisomeric forms that are incompatible with one another. These isomers have equal physical properties, such as melting point, boiling point, refractive index, density, solubility, and so on, despite the change in atom arrangement. They are also similar in most of their chemical interactions. They only differ in their behavior when it comes to plane polarized light. One rotates it to the right, while the other rotates it to the left, but to the same degree. An optical isomer is a pair of chemicals that have the same optical properties. Optical isomers are two compounds that contain the same number and type of atoms, bonds, and spatial configurations of the atoms, but are not superimposable mirror images of each other. Enantiomers are isomers that are non-superimposable mirror reflections of each other. FAQs on isomerism. Question 1. What is isomerism? Answer. Two or more compounds with the same molecular formula but distinct physical and chemical properties are known as isomers. Isomerism is the term for this phenomenon. Question 2. What are the types of isomerism? Answer. Isomerism can be divided into two categories. Stereoisomerism and structural isomerism are the two types. Structural isomerism, chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism, stereoisomerism, constitutional isomerism, conformational isomerism, optical isomerism, geometrical isomerism. Question 3. What is ring chain isomerism? Answer. Compounds with the same chemical formula but open chain or cyclic structures are known as ring chain isomers. Ring chain isomerism is the term for this phenomena. For example, the molecular formula C3H6 represents the ring chain isomers. Question 4. What is chiral carbon? Answer. The carbon atom, which is attached to 4 different functional groups or molecules, is known as chiral carbon. Question 5. What is structural isomerism? Answer. The structural isomers or constitutional isomers differ in the connection of their atoms, and this phenomenon is known as constitutional isomerism. There are 6 types of structural isomerism. Chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism. Question 6. What is positional isomerism? Answer. Position isomers are two or more compounds that differ in the position of a constituent atom or functional group on the carbon skeleton, and the phenomenon is known as position. For example, C3H8O represents 2 alcohols. Question 7. Which type of isomerism is possible in CH3CH is equal to CH3? Answer. H3C, CH is equal to CH, CH3 and H2C is equal to CH, CH2, CH3 are the possible structure of the given compound, and as the position of double bond is different in both the structures. Thus, CH3CH is equal to CH3 has positional isomerism.